now. Okay, this is week 14, the week before the final, and I am going to be giving you areas of concentration of study for you. And this isn't an instructional video, it is more of conveying information on what you need to study for on the final. So I'll be going through here. There's just so much in the book that the reason I'm doing this video is so you can hone in and skim over non-related material that are in chapters 10, 13, and 16. So here we go. I would like you to know what atomicity is, durability is regarding transactions and database state. I'd like you to know what a shared lock is all about when we have concurrent transactions, what a transaction is as a logical unit of work. I need you to know the 4 events that signal the end of a transaction with commit and rollback purposes. I need you to know what commit and rollback mean. I need you to know what a deadlock situation is, so that as long as 2 transactions that are unrelated in what they access, their order of execution doesn't matter. But otherwise, there's a possibility where one is waiting upon the other and the other is waiting upon the other. It's a mutual stalemate, known as a deadlock situation. So when we access data and we would want like concurrent users to access the same data, we lock out at different levels. And granularity is where we look at the level of the lock in question. So you need to know different lock levels, whether it's the database level, table level, page level, row level. There's something called table space level. You don't have to worry about that. Data store. Now, when we get into decision support versus versus operational data, you need to know a number of things in that regard. So, data stores. What do data analysts use to create queries that access the database? And is it a data warehouse or is it an operational database? Operational database uses OLTP, online transaction processing, to access and update the data, where decision support systems use, OLAP, online analytical processing. You need to know that the purposes between the two are different. Data warehousing, you need to know that they're organized much more in a summary fashion. So if you were to look at the details within one table, a table at a time, that wouldn't be what decision support is. Decision support is where you're combining a lot of data and you're not worried about normalization and the updatability of it, just on how you slice and dice the data for business intelligence purposes. And when we look at data stored, we need to look at periodicity, which is, are we looking at current data or historical data? When we look at historical data, how far back do we go? And so you need to know the different time slicing arrangements, especially when we look at a data warehouse and we summarize a bunch of data. Is it going to be updated every week, every month, every year, that sort of thing? And then we can use data mining tools. And when we use data mining tools, it's the list of characteristics that we would like to define is a moving target. So it's a more, much more dynamic and fluid in data mining tools. We would rather have things very bite-sized pieces of accessing and updating the data if it's operational day-to-day. So when we look at the data warehousing world, we need to employ business intelligence. The goal of business intelligence will allow us to capture not only the business data summarized inside the company and without, but also metadata, which is the data about the data. And so so decision support data is very key to business intelligence. When we look at a data mart, that's the governance section of the business intelligence framework. So we need to know when we encapsulate our fuller data warehouse and we use data marts, it'll be for the purpose of governing the data that's in there. Study up on that. Looking also at external data resources versus internal that we get maybe from an operational database. We can put that in what we would call a data store. And it can be near real-time basis for the data warehouse, which is usually the case, or it can be summarized annually and that sort of thing. Now, from a data analyst point of view, decision support has three major areas of distinction: time span of the data, granularity of the data, how detailed does it get, and also its dimensionality. So study up on those three. And also look at data integration, which will refer to how we describe in the same manner our characteristics of the data attributes and entities and so forth. Integrate that into a similar description so that anyone in the corporation knows the corporate data language, if you will, to access their data. Common abbreviations, a whole bunch of other things come into that. So we can look at the names of things and already be not guessing about and looking up abbreviations all the time, but as you day to day look through your business in terms of data, analyzing your data as data analysts, the business intelligence will come more to life if you're more common in your vocabulary and how you describe things. So there's a life cycle that comes with our systems development for the operational world, which differs from the life cycle that would be in the data warehouse development area. We would need, for the data warehousing development, we need data visualization tools that allows us for end users to look at data in a plethora of different fashions, and it's just how we materialize it to the user in terms of visual aids like charting and how we summarize things through graphics. Okay, and then another major difference is operational data is normally very highly normalized so that we don't have anomalies when we update data. Whereas decision support, since we're not in an update, and in fact, if we do update for what-if analysis, we can pollute the data and not have to worry because we can always refresh the download from our operational environment for our data store to refresh the data warehouse. So we don't really care about its upkeepability, if you will. So it should not be highly normalized. And it can be repetitive and repeated and so forth. Redundant data in so many places in the decision support world. Okay, and now we can go over now to the third area of study, Chapter 16. I just discussed transaction management in Chapter 10. I just discussed decision support and data warehousing in Chapter 13. Now we're going to Chapter 16, and Chapter 16 is talking about the different activities like data administration, database administration, data security officer in our upkeep of a database, administering a database, Chapter 16. So data administration, now these terms are going to be highly individualized by corporations on how they really want to refer to it. A database design group, maybe that's called a data administration group, which we'll use here in Chapter 16. It could be referred to as information resource management. It can be referred to as information engineers, that sort of thing. But let me just say that the way that I would like you to remember it is DA versus DBA. So DA is all about the business aspect of our data and managing it from that standpoint, even regarding high-end data modeling, going down into from the conceptual to the logical, to the eventually the physical, where we hand it over to the database administrators whose major chore is not planning and design and analysis, but support on a day-to-day operational basis. DA versus DBA versus Data Security Officer, Information Security Officer, which deals with the business needs of the company and seeing that they get translated into the DA and DBA people to implement it on a database, on a day-to-day standard. But they would talk to the outside agents that are stakeholders in our business regarding our data. Okay, as always, administrator is more support-oriented, engineer is more design and planning and design and analysis, where the administrators are more support. So we could have a database administrator, data administrator versus the database engineers, information engineers. The DBA's role is usually technical in nature as well as being operational day-to-day. If you're a creative sort of person, you might want to be on the DA side, interfacing with end user communities and the database security officer. If you're more on the techie side, operational support, you might want to go towards the database administration direction in the database field. The database field is very broad, very lucrative in terms of its opportunities for advancement, for staying in that whole area for your career if you wish. It's that broad and deep. So that's an emphasis of your career. Maybe you want to start off on the technical side and then from there move into the planning design side, doing data modeling and interfacing with the business people of the corporation. Okay, a few more things where we have policies that need to be designed for, and then when we come up with them, then enforced. Policy is something like, okay, how long are we going to allow users to keep their password retained before they have to change it, et cetera, et cetera. There's a whole lot of security policies that need to be put in place that the database security officer would be primarily responsible for. And then to support our database world, we need to keep in track of a couple tools that we mentioned, the data dictionary, but I also want to mention case tools. And we'll end with this. Data dictionaries go hand in hand with the DBMS. There's the part of the data dictionary that is your system catalog, which is operational. So if you were to create a table, the metadata has to be updated by the system catalog to keep track of the definition of all your database objects. We would refer to that as the system catalog part of the data dictionary. And the extensible part, which is handling the business descriptions of even all the way down voluminously to all your data attributes and a description of every attribute, they will get higher in level and then talk about your tables, documenting them, documenting your areas of the business that you are implementing with both OLTP and OLAP, and we would have that to be backing up your, to a lesser degree, the decision support area, but to a more degree, your operational data, so you know where to get to it. Data dictionaries can also be put in terms of passive or active. It means that a passive data dictionary is not updated automatically. You might need, and that might even include parts of your system catalog where you would require a batch process to run the updates to the necessary parts of your data dictionary. That is not dealt with as much anymore. Our tools are more sophisticated nowadays, but the passive data dictionary does come into play about your business descriptions. That wouldn't be done automatically. That has to be done by data administrator types that will document your attributes, your tables, your databases, etc. Okay, but the active data dictionary is automatically updated with all your database accesses, and that's mostly system catalog oriented. And lastly, your case tools, computer-aided software engineering tools, they help automate the development lifecycle, planning, analysis, and design phases, even towards your implementation. Uppercase, or known as your front-end case tools, play on words, your uppercase tools, they're on the planning, analysis, and design phases. An acronym to remember is PAD, so you can easily remember planning before analysis, analysis before design. But after the design phases, when you start implementing and then maintaining, we will refer to the back-end case tools or the lowercase tools. So uppercase versus lowercase computer-aided software engineering tools. And those are the areas that you need to study for the final and know and read deeper into the textbook about to be able to answer the questions on the final. And I won't be asking you questions dealing with any areas that I just did not discuss right now. So that should help you in your final study. Okay. Let's stop this recording.